So there we are, and we are live. David, we're just getting the participants coming through now. So we're up to about 30 already, growing quite quickly. So very shortly, you are good to begin your webinar. Enjoy the speech.
Thanks, Zach. Appreciate it.
So am I ready to go now, Zach?
You are indeed.
Okay.
He's gone.
Well, I think we've probably got all, at least the majority of the attendees there now. Good evening, everybody. This is David Henry speaking. I'm the chairman, and welcome to our first edition of our second phase of COVID lockdown Zoom presentations. We're pretty familiar with it, having done them last year for quite a couple, 2 or 3 months. So hopefully this will go I know this will go very smoothly tonight. And we have a very interesting talker in Ian here from the SIMS organisation, who's going to talk to us about the East Australian currents, which is very important or very interesting to every yachtsman who sails on the east coast of New South Wales. And just before we start, though, I'd just like to firstly thank you for attending tonight. We have a very good enrolment, and I hope you enjoy it. But I'd just like to let you know what we've got planned for the next few months, because it looks like we're going to have another Zoom presentation next month at least. So we've got quite a good schedule of talks coming up. So in August, in a month's time, we'll have John Vaughan, the well-known vexillographer, who'll talk to us about flags and the application of flags on yachts and flag protocols and the types of flags that are available. And I'll probably mention the new squadron racing flag. September, October, November, we've got a lot coming up. The one we had to cancel last month when the lockdown started with the Maritime Museum speaker, Noel Phelan, talking about the midget submarines in Sydney Harbour in the Second World War. We're going to move that to November, and hopefully that'll be a live presentation. In September, we've got a very exciting anecdote or long story about one of our members who was involved in the wreck of the Endeavour 2 on the coast of New Zealand a few years ago when he was a younger man. And October, we're probably going to be talking about some of the lesser known histories of around Sydney Harbour, places you know, and probably things you didn't know about them. So that's what's on the agenda in the future. And so let's move on to Ian now. I'll hand over to John to introduce Ian, and then we'll get going on tonight's Zoom webinar. Thank you very much.
Thank you, David. It's John Hancock. I'm a member of the committee, the cruising committee, and my pleasure to introduce Ian Suthers. I'd just like to tell you a little bit about Ian. He's a professor at the School of Biological Earth and Environmental Sciences at the University of New South Wales, and is now based at the rapidly developing Sydney Institute of Marine Sciences at Chowder Bay, a collaboration of Sydney-based universities, state and federal agencies. He was the inaugural chair of the New South Wales Integrated Marine Observing System, 2007 to 2012, which is one of 5 nodes of the $102 million federal Integrated Marine Observing System program. Of prime concern are the warming waters of the southeastern Australian current, which has risen more than 2 degrees C in less than a century. He completed his PhD in Canada and postdoctoral work in Norway, as well as back home in Australia before taking up a lectureship at University of New South Wales in 1991. Now, his most recent expedition was on the brand new Australian Government Research Vessel Investigator, owned by CSIRO, working off the New South Wales and Queensland coast. Ian is a biological oceanographer concentrating on marine species. He explores the basis of sustainability of estuarine and coastal ecosystems. His talk tonight will begin with a tour of the major contact points at Fraser Island to Cape Byron, Smoky Cape and Eastern Tasmania. The effects of the EAC are evident in shifting corals and tropical species into New South Wales and sea urchins from New South Wales into Tasmania. His research has shown how the East Australian current flows and why Finding Nemo was just half right. My pleasure to introduce Ian, who's smiling to you now on the screen. Thank you, Ian.
Thank you very much, John. It is a pleasure to be here, and thank you all for coming along tonight. I'll just share my screen. And I'll just, there we go. So thank you, John. So my topic is where Finding Nemo was half right. In fact, it wasn't too bad, that Pixar movie, in showing how Nemo's dad, Marlin, and Dory went through the swirling vortex of what's shown here on the right-hand side of my screen, the East Australian current. I'll just also just use this little pointer here so you can I can talk about myself and click through these slides. So the first thing to observe is that here in Sydney, we live so close to this major boundary current. It's a river of warm water that drains from the southern Coral Sea down into the Southern Ocean. And it's less than 30 kilometers away, and it really controls our climate, our fisheries, the value of this very valuable marine ecosystem, the temperate rocky reefs are part of about a quarter of the blue economy, which is valued at around 50 billion a year, and is forecast to grow 2 to 3 times the GDP over the next 10 or 20 years. So it's an amazing economy. And here we are, this major populations of more than half of Australia, Brisbane, Sydney and Melbourne and Hobart, are just influenced by this warm water that interacts with some cold air off the land. So here is the diagram here of the East Australian current, the EAC. And you can see this complexity of these flows of the eddies and gyres, and the separation zone, which is where I want to concentrate, just off the coast of Sydney here. And it then it basically splits in half almost. Half of it forms an eddy field going all the way down to Tasmania, which these eddies then slip around the south and actually head west. And the other half forms the Tasman front, and it's pretty chaotic, really. It's not a nice linear front. It's controversial, called the convergence. And it forms the EAC of New Zealand. It's called the East Auckland current. The water that arrives in here is spent about 2 years crossing the Pacific in the South Equatorial current. Here, the South Equatorial current, as it goes through New Caledonia, and it splits and forms this Hiri current heading up north in the EAC. And the action happens here in the Southern Coral Sea. The implications are, as John just alluded to, shows you, this is perhaps the busiest graph of the entire talk, showing, and it's the best one, it's a bit old now, but shows you temperature from 12.5 to 15.5 degrees at this crucial monitoring station that was set up in 1945, just after World War II. And it shows you temperature against salinity at this site here off Maria Island. And the Hobart researchers set it up, and when CSIRO moved down to Hobart from Sydney, from Cronulla there in 1980s, they continued it, and it's absolutely rigorously maintained. And temperature and salinity basically tells you like you're moving from a desert to a rainforest. This is the indicator of the marine environment that we're in. And what it shows is it's color-coded here for cooler water back in the 1950s up to warmer water in 2009. It's continued, of course. And then they've put what that temperature salinity environment corresponds to which the latitudes. And so it started off at just off Maria Island, of course. And by 2009, 2010, it's gone up to 40 degrees off the southern middle of Bass Strait. And essentially the temperature and salinities of the coastal ocean have moved about 350 kilometers south. So we've pushed all those conditions. Now these differences in temperatures and salinities don't mean that much biologically. Well, salinities don't. It's just a measure of the water mass, but the temperatures have certainly changed, and has enormous influence on animals that rely on they're what we call ectotherms. They rely on the environmental temperature. So this has had manifest implications for delivering sea urchins from New South Wales into Tasmania, which subsequently eat the kelp, and interacted with the fishery, which has over-harvested the lobster. It's brought in more than 20 new species of fish into Tasmanian rocky reefs as well. So you can see it's getting warmer, it's getting saltier. It's driven by the strengthening East Australian current over the past 4 or 5 decades. This is because it's the western side of a vast South Pacific gyre, this massive circulation of water in the South Pacific going from Australia across to South America. And this gyre is spun up and driven by the westerly winds in the Southern Ocean as they're pushing the bottom end of that, the southern side of that gyre, causing the big rotation to speed up. And this was predicted in publications back in the late 70s and 80s. And the predictions have been very good and have carried on for the next 30, 40 years as this thing is gradually speeding up, bringing down this warm water. So in my talk today, I want to talk about the tools that we use to measure the East Australian current and what John mentioned about the Integrated Marine Observing System. It was established just over 11 years ago. It's now sort of locked in. There's been cuts and changes to make it more, drive down the cost of each observation has been the mantra. And it's about 18 million a year. And you use the ships of opportunity. They got AUVs, autonomous underwater vehicles, that monitor the arrival of corals and the disappearance of kelp off New South Wales. We have these autonomous ocean gliders that measure temperature, salinity, chlorophyll of the water. These Argo floats, that go into your daily weather forecast. I'll talk more about those later in the talk. And these fascinating acoustic telemetry that they put in fish and sharks that's shown that the bull sharks in Sydney Harbour in February end up off Townsville in winter. And they come back again every year reliably, unless they're caught, of course. So it's a remarkable system, and it's really got marine scientists to act like astronomers who have been very successful in getting their act together, working collaboratively, lobbying for funding, and making sure that the data is useful to everyone from industry to students, to consultants, to oil and gas. And that's, if we don't do that, we don't get our money. So the second thing I want to talk about is, where does this image come from? It shows you just the most recent one where I got it from. I'll show you just the last few days, from 22 degrees is the red down to blue for 15 degrees. And there's the arrows that show you the flow at 1 knot current in the distance over just 6 hours. So 1 knot is 1 nautical mile per hour. And that's a 6-hour drift. If a bottle was chucked on the surface, that's how far it would go. The blue arrows come from another piece of technology that's deployed at Seal Rocks and off Newcastle. So I'll talk about and what these white lines and the white, of course, are the wind speeds. And the EAC is just this remarkable current, and typically 3 to 4 knots, but we have had observations of 6 knots, which is just extraordinary. Yeah, it's outrageous. We questioned the instruments that delivered that, but you can see this is a fish attraction device, a FAD off Coffs Harbour, and sometimes these things disappear from the surface because of the strength of the current. This current was first observed by Captain Cook back in April of 1770. And he was just off this area. He was he was sailing up, and a southerly caught him. So he hove to and waited out the southerly, as you did in those days, without much fuss and bother. And when the sun came up, he took his position and found, to his surprise, that even though the wind was blowing from the south, he ended up going back into the direction of the wind. And he said, there must be a strong current pushing me along here. And indeed it was. It was the East Australian current. I'll conclude with a bit about the RV Investigator and what an amazing ship it is, delivered in late 2014, and now it's fully funded for 300 days operations a year. So a great place to start about the EAC, the East Australian Current, is to just have a quick little tour. Right from just off the image here is Fraser Island, where it's actually the East Australian Current does a 45-degree turn. And this is the big South Coral Sea pool, and it roars down past North Straddie, past Cape Byron, off Coffs Harbour, Smoky Cape, Seal Rocks, and then Sydney and beyond. And this is the separation as it goes off to either New Zealand or the eddy field down to Tasmania. And I'll tell you where we get all these arrows. So the headwaters are off Fraser Island. And it was here, actually, Matthew Flinders went on to Sandy Cape up here, actually right up here, and it was pretty bleak, but he could see that this is where the really warm and actually less saline EAC water brushed against it and then began its journey down south, actually offshore usually along the continental shelf. Off North Straddie at 27 degrees south, it's where it's most coherent is our jargon, our term, they call the torrent. And this is where we would deploy those current meter moorings to measure the EAC. It's where there's lots of numerical studies trying to measure, can you generate electricity and power from where it's most coherent, where it's most linear and not as complex. At Cape Byron, at 29 degrees south, is called the mini separation. And this is where the EAC begins its first venture to split away from the coast, away from the shelf. And doing so, it drives cold upwelling water sometimes. So this is, as I say, I'll describe what these arrows are and what they mean. But you can see there's Cape Byron, and this happens to be associated with a cyclonic eddy, and it's split away, and it's driving up cold water. And at that time, back in early 2019, if you can look at the corresponding image, this is sea surface temperature, see from 19 to 28, so cold water off Port Stephens. And this is the corresponding ocean color, that is the chlorophyll. And it's the standard international applied algorithm, which is has to be translated for local species and conditions, but nevertheless shows you how much chlorophyll is in the water, and red is for lots and for blue is for not much. And you can see it's ripped off this chlorophyll in this cooler water in this cyclonic clockwise eddy here. And that was associated at the time with that shark attack. And we get 2 or 3 of these per year. And it's still a work in progress to understand how the ocean climate or the ocean weather, I should say, varies to lead to these sorts of conditions. And wouldn't it be great to have a forecast of risk for these incredibly rare events so that we can understand it better? But it's often associated with cold water, with these eddies, and with chlorophyll, which brings in plankton and then forage fish, and therefore they mix up with humans. On the way down is this other solitary islands, part of the marine park, and these are now becoming what we call tropicalized. And there are areas, the offshore islands have lost their kelp, and we've got underwater video that was just routinely collected by interested people. And in the background, you can see from videos in the 1980s, lots of kelp, and now the exact same site today, 20 years later, and its growth of coral. So the corals are spreading south and the kelp is disappearing. And what effect does this have on that great, blue economy of temperate rocky reefs? At Coffs Harbour, 30 degrees south, there's big investments from IMOS and Sims here with 2 ocean moorings. We put out the Slocum gliders from here. We also have a radar system that measures surface currents in real time. I'll talk about that in a moment. At Smoky Cape, it gets interesting. This is the pinch point. Here, the shelf is only 15 kilometers wide. There are strong southerly currents, and any sailor heading up north towards Coffs or Brisbane has to somehow hug the coast right here off Smoky Cape or plow into the EAC. It's, of course, going home, heading back south, it's great, isn't it? You get a free ride. But it's really challenging here, especially if you meet with a southerly. So you can imagine a strong southward set of the EAC and a southerly wind. It really steepens up the seas and makes it quite dangerous. I was just mentioning to David and John that when we were just in May on the Investigator, we were asked to survey a particular site where a cargo ship went down just back in 1968. Loss of 20 lives and only 3 survived. And it was exactly an East Coast low where you had strong EAC current and a strong southerly wind, steep seas, and the poor thing was overwhelmed. Excuse me. I find Smoky Cape, really interesting. The shelf is only 15 kilometers wide. It's one of the narrowest shelves in the world, and it quickly runs down the slope into the abyssal deep down to 2,003 and then 4,000 meters. And we've, particularly in a few areas, we've now using the investigators' acoustic technology, you can produce these beautiful maps showing you these canyons. These canyons are slump zones where the sea level rose about 12,000 years ago and flooded the continental shelf, and the sand just, so they're not very, we've put cameras down in there, and we've looked baited cameras to see the sharks and the hagfish and so on, and you can see they just sandy gullies with occasional rocky outcrops. But my point is that the EAC is flying along the shelf here, hits these features and drives water, we think, up these canyons onto the cold water, deep water up onto the shelf. And I'll describe this mechanism in just a moment as well. In fact, right now. So this is a great little cartoon by my colleagues, Peter Oak and Jason Middleton, where the East Australian current is shown here going past Smoky Cape. And it's one of the four main mechanisms that drives the upwelling and the cold water, especially if some of you have holiday cottages at Laurelton or Port Stephens, and it's freezing cold. Well, you can thank this process, because there's also headlands, topographic effects. Northeasterly winds can do this as well. But what it does lead to a cold surf on a nice hot Christmas holiday. And in fact, because of this mechanism, as these EACs up here north, it's in nice, what we saw, say, it's in geostrophic balance, meaning that the buoyancy, the drivers, the Coriolis effect of the rotation of the planet, everything is a nice little balance. But that balance gets upset when it scrapes along the bottom here of Smoky Cape, which causes, upsets the pressure gradient, and it draws up deep water. And that appears as cold all along this coast here, especially Port Stephens, Laurelton, and faster cold waters. In fact, because of this mechanism, especially as the AC steps up a notch during summer, that winter water temperatures are often warmer than the summer temperatures because of this mechanism. So if you're a grey nose shark on a reef, our summer is their winter, and our winter is their summer. So they're enjoying summer right now. And yeah, if we help convey the point. And the last real point of contact is here at Seal Rocks, just north of Sydney. This is where you can see the EAC now forms, the East Australian current forms an eddy field. Here's this eddy is about to pinch off. And we'll describe what all these lines and arrows mean in just a moment, bear with me. And this is the Tasman front, or some people call it the Tasman convergence. At Seal Rocks, it is the turning point. And so we've, in the last few years, Sims and IMOS have put in a second set of these antennae just here and here on the cliffs. And I was actually scrambling around out here 2017 to find a good spot and doing all the negotiations with national parks to record the surface currents in real time. And this actually observes the surface currents rather than all those other black arrows, which is just from satellite. So here's Sims there, putting up, this is the transmit antenna, and up here, up under that little ledge is the receive antenna. And we've got a little sign there illustrating it, and we've, through the Australian Communications Management Authority, they've been pretty onerous and making sure that we're not interfering with other people that use this particular frequency. And because of that, it's now been made directional. It used to be omnidirectional, but now it's just faces out to sea. And at 1 watt, it was designed by the Californians for 60 watts, which we thought was pretty low. It's like the old-fashioned light bulb. And now it's operating at your basically little transistor radio type wattages. But it can get out to 200 kilometers offshore and give us 6 kilometer sized pixels. Now, that's what those blue arrows are. And here we are installing it right on the edge of the cliff and digging trenches, put the cables in, and hopefully dodging any bushfires that would go out there. There is a second system at Coffs Harbour. This is a more sensitive, it's a German product, the Wera at 25 megahertz. It also operates now on just 1 watt, but it is a directional, what it does is from Red Rock, it puts out these, it measures the return frequency, slightly Doppler shifted because of the waves, and the one from Nambucca does the same thing. And where this intersection occurs, it does the triangulation and gives you the surface current so you can compare. These little tiny arrows here are now a mathematical model, and you can see how behind there, the temperature as this eddy is going through the system, the East Australian current. And but it's a great place, Coffs Harbour, for all kinds of reasons, for these moorings, the wave rider buoy network that's along the New South Wales coast, the marine park, and we see all these fish and sharks cruising by. We've put tags into. So I've now brought you down to Sydney, and that's your little whistle stop tour. And now I'd like to talk about some of these features and get into what I promised you is how to interpret these images and how you can use them to help you sail better. Sorry, this is the sea surface temperature here that you can, I'll show you the website. We just get this courtesy of the IMOS program. And there's a whole bunch of other little features in here we're going to drill down into, but you can also just click across, for me, the biologist, to look at the ocean color. And so this is the most recent ocean color. You can see there's lots of cloud cover out here, and you've now removed the sea surface temperature and put in what the ocean color is. So it's just, they use red for about 4 milligrams per cubic meter, which is actually quite a lot. You know, you'd notice that it's perceptibly noticed it's greenish water in here. But this was in the middle of our, obviously, winter right now. So I got another image, went back into the archive and dug up one from last year, in January. The East Australian current is really cranking there, and you can see how much more, up to 4 micrograms per cubic meter. So the chlorophyll is the pasture of the coastal ocean. This is what feeds your prawns and feeds the crabs and feeds the larval fish. It's the bottom of the food chain. If you don't get this, then you got a very hungry planet. And so it particularly occurs up against the coast. It's not just East Australian current driving up that upwelling, but also just a bit of outflow from the rivers. A bit of sewage off Sydney always gives a bit of nutrients, and the waves and churning of it on the narrow shelf is where we get our fisheries production. So this is all the cloud cover, and where do all these arrows come from, which I've been promising you. They come from measuring the surface, the sea level of the ocean down to the precision of 1 centimeter. So these guys, these satellites, actually it's the Jason 3 now. This one's become defunct, I think. There's a couple of others, and they each one of these goes around the planet every 10 days, 127 revolutions every 10 days around the Earth. They just go from 66 down to 66 south. It's in low orbit, and they ping the surface of the land and, of course, the sea. I like this image here. It looks like it's vaporizing it, but don't worry, it's just measuring it. I think it's a bit of artistic license here, but it shows you the highs and the lows, the red for high and the blue for lows. So the sea level anomaly, that is the difference from the overall average, the geoid, which is the shape of the surface of the planet, it subtracts that from the sea level to measure this incredible precision. I've spoken to a few oceanographers who are very good mathematicians, and even they roll their eyes. Apparently, it causes them, for mathematicians, it makes your eyes water, but it's quite remarkable. So just to sum up in a better, I think, image, so it subtracts the Earth's bumpy surface, the geoid, from this height here done by the altimeter on this dedicated satellite funded courtesy of the Europeans and the Americans. But we contribute a lot to calibration and having moorings to check on this. So Australia is in there very much. And these highs and lows are directly akin to meteorology, high and low pressure systems. So I've whited out the northern hemisphere, but you can appreciate in the southern hemisphere, you get a bump, as you got here, of sea level and water, and this is over hundreds of square kilometers. So the height is a trivial amount. They 60 to 80 centimeters high or low. See, that's all it is, over hundreds of square kilometers. But nevertheless, that's sufficient for water to run downhill away from that peak. So it runs downhill, but on the planet where you got a flow like this, there's advection to the left in the southern hemisphere. And so you get this anticyclonic, anti-clockwise rotation around a high, just as you do in the atmosphere. And where you get a depression like you have here, then you also have water flowing into the depression. There's advection to the left, and you get this clockwise circulation around these little dips in the ocean. So they take these highs and these lows, and they put them into a computer model that also takes into account the effect of tides, of sea level against the coast, of air pressure, and it then creates this distribution of sea level. So there you see, there's Sydney just in here at 34 south. There you see a little dip in the ocean, and it's nearly 60 or 50 centimeters deep. And then you have this high here of nearly 60 centimeters high. And you can see all these little dots here. These are different age dots too, as the satellite passed over, different tracks that are all, so some tracks are early, some are over the 10 days. And then it calculates then from this, applies an oceanographic model to calculate these arrows based upon what I described, advection to the left and the Coriolis flowing away. Bit of cloud cover here, and they then remove this sea level anomaly and paste on top the sea surface temperature, which is much more useful to you and I. So there, now you've got temperature from 12 degrees to 26, 12 degrees down here to 26 up here, and you have the drifter velocity here. And these drifters are about to show you what these guys look like, are independently observed for what the computer model thinks. And sometimes the computer model gets it wrong, but these little drifters here don't lie. Excuse me, I'm just going to tell my kids to stop yelling so much in the room next door.
Fascinating stuff, David.
Sorry about that. There's a bit of a party going on. I guess it's a COVID-inspired one. So, right. So and we've subtracted the sea level anomaly. We've put on the sea surface temperature, and we've got these drifters trying to check on that computer model. So this is now what we've created. Now I've got rid of all the nasty image that had to have cloud cover. There's a bit of pixelation here due to moisture in the atmosphere, but never, it's a pretty good image. And you can see here we've got this anticyclonic in the southern hemisphere, anticyclonic, anti-clockwise. Southern hemisphere, it's a warm core eddy because they're typically warm because they're slightly downwelling, it drawing water in. And you've got this a cyclonic clockwise eddy in the southern hemisphere, which is slight upwelling, and these ones are very productive typically, and these ones are typically quite like deserts typically, but they're always interesting exceptions. And we've got, and this is, I've said NB over here on the, to remind me, this is, even though this is an old image back from 2016, I put it in here deliberately to show you the classic case where the black arrows, you've got to use it, you've got to get three pieces of information here. The black arrows are from the computer model from the satellite, sea level, and it's made a mistake because it's going over at right angles to what the sea surface temperature is, SST. Now, sea surface temperature doesn't lie. That is good, robust observation, and indeed, the Lagrangian, these floaters, these drifters, these satellite track drifters. I'll show you a picture in just a second. And the size of the arrow is how fast they're moving. It's cutting right across at this. If you show this to our oceanographic colleagues, they blush and they're a bit embarrassed and said, yeah, we fixed up that problem, etc., because it was a few years ago. But there you have it as a great example why when you look at these images on the white lines are just the sea level that I mentioned to you. This is a little trough and this is a little hill. And there's actually, they used to have tidal gauges here that also influences this, but not on this image. But you just need to look at three things. You look at, obviously with the black arrows are so compelling because they show, well, that must be this Australian current. Not quite. You need to include then the movement of the drifter, and you need to especially look at the sea surface temperature, and that really tells you what's going on in case there's some kind of mess up, especially this kind of confused area here. It'd be hard for anyone to figure out what's going on. And so now if we're going now just off the coast, this is, you can do this right across the planet. They of course, and they've done a global synthesis of all these eddies and these currents and how they're changing. So this is called the separation zone, just south of Smoky Cape, where there's brings up all this cold, nutrient-rich water, which dries and feeds all our fisheries and makes life sometimes miserable during the Christmas holidays. We've got this big warm Corellian that's starting to pinch off before it's going to float all the way down to Tasmania. You've got these little drifters and these little circles that are on this image are Argo floats, and I'll describe what they are. There's one down there, for example, has just come up. It's talking to a satellite, and then it's going to drop back down again to the safety of the depth. And we've got this little cyclonic eddy here, which is, I've sampled these, I know it. They're chock full of larval small mackerel and sardine. Yes, sharks like to get in there. And now that the fishermen have got this product, they can go out and set their long lines into these sorts of areas. So it's quite busy. Yeah, it's bitterly cold water off Foster and Bluey's Beach. Look at this in March. It's the warmest time of the year of the ocean temperatures in the autumn. These is what these drifters are. Lagrangian just refers to, it's a fluid dynamics term, something that drifts along a track rather than a Eulerian current, which is at a current meter. They chuck these things in. That's the battery and satellite, talks to satellite, and it measures air pressure. And it's got this big drogue that's about 15 meters deep, and they drift around the oceans for about nearly 10 years they can last. It's these things that contributed to understanding this wreckage from the Malaysian Airlines airplane that disappeared in the Indian Ocean, MH370. And what was really unusual that brought about that sometimes when these things get old, the shackle gives way and they become undrogued, and they could through computer analysis, they could sift out the ones that had lost their drogues, and those ones were drifting along the way stuff does, flotsam at the surface of the ocean does. And that's when they realized where they could do a whole different kind of analysis, not a drogued drifter, but an undrogued one. And a lot of the stuff ended up on Reunion Island. Also, by the way, these barnacles, I had a couple of students looking at this to investigate how you can use the forensics in tools that come with barnacles attached to any drift object in the ocean. I'm very interested in these. Also, the Lagrangian drifters have contributed to understanding the flow of garbage into the global ocean, and epitomized by when this ship here, about actually 10 years ago now, it lost these container of little tub toys, including duckies, but also alligators and stuff. And they went all around the global ocean to show how we're all interconnected. And this has led to this magnificent analysis here. You can log in there and just click on little ducky onto anywhere on the planet and see where garbage gets after 3 years or 10 years. I mentioned about these Argo floats. These are amazing, good news international story that has the entire nations of the world contributing. So these floats, they cost about 20 grand each. They're designed to, with a little a density engine inside a little piston. They will park themselves at 1,000 meters, and on the 10th day they drop down to 2,000. Calibrate their temperature and salinity electronic sensors, the safety at this very stable depth, and then they'll rise up over the next day, recording temperature and salinity every meter, talk to a satellite, gives you the flux and temperature from the ocean to the atmosphere, and vice versa. It's these Argo floats that have in the Indian Ocean that have led to the prediction of this coming spring being quite wet, which I guess is good news for as long as they're not too wet for Australia. And this is the daily weather forecast. It comes from these things, and we don't really appreciate it. How they work is they've got just a battery, a little piston, a motor, and this hydraulic bladder that changes its density. So when it has to go up through the stratified ocean, the tropical ocean, this has to work very hard. And it lasts for, as I say, if they're done, the Australian ones can last up to 8 years. It's worth every penny of the 20 grand each. So we put out a few of these on this recent voyage just to keep the population, for those that then sink to the sea floor. They repopulate it every few years. And if you go to Wikipedia, this is the most recent distribution of all these floats and who owns them. There's Australia with 361 in pink. The US owns the lion's share of 2,000 of them. And but this is our patch, and we have to look after the Southern Ocean, and Australia definitely punches above its weight and does a fantastic job, along with New Zealand. It's really, we have a great working relationship with the Kiwis. So yeah, I've just returned from this magnificent ship. It's Australia's premier oceanographic research vessel. It was built in Singapore for 120 million. Lots of investment from Geoscience Australia for some of the kit inside for, yeah, looking for oil and gas. Yeah, I know, ironic. But also fisheries. On this mast, it measures carbon dioxide and all kinds of incredibly sensitive instruments to measure duration of an air mass at sea. And on the top is this great weather radar that measures the dynamics of the monsoon up in Northern Australia. It's a really stable ship. So it's a cruise ship technology. I took this picture actually on the maiden voyage out of Hobart. And we went into 40 knots and there were some 4 meter seas around the corner. And I was really impressed. But inside, the students were looking at their computers and just doing stuff. It seemed to be oblivious because it's got this 150 tons of freshwater tanks, and the computer just controls the roll. It's a standard technology, but it means that when you've got a very expensive vessel, you're not wasting time with seasick scientists, throwing up onto the computer screens. And we left Hobart and went up, did with all the moorings to do these East Australian current moorings. We collected samples, plankton samples off Coffs Harbour, Port Hacking, Coffs Harbour, but most of the time we spent off North Stradbroke Island, particularly this little feature here, that little cold cyclonic eddy, which was full of little fishes, anchovies. It was quite exciting to work. But these moorings here, there's 6 of them. It's about 4.5 kilometers deep out here. And so here they have these 1.5 tons of railway wheels as the anchor, and streaming away 5 kilometers off towards the horizon is an array of instruments. They've got an acoustic release there, so they'll get it back in 18 months' time when the batteries are low and the memory is full. Little parachute there to control its descent. Sometimes these moorings come up covered in festooned with fishing gear. It's a remarkably slick operation these guys do. And up there, the weather's beautiful. And this is what we do at night. While the mooring crew rests, at night we get busy, and we're just sampling for basically larval fish, and particularly had a colleague from Griffith looking at the jellyfish in this waters. Yeah, so there's another picture just showing you how they're working together to raise it. You can imagine all the safety gear that goes on. There's that's the final float pack there, and that's the little parachute that's going to control its descent on the seafloor. And there's the acoustic release is just I'm not sure, it's a little acoustic release. There's a pair of them, and then when it got a signal, it releases from the weights from the seafloor. This is a float, obviously, that has an acoustic Doppler current profiler. It's similar to what your doctor uses to measure your blood flow in your veins and your arteries. And this thing just sends out sound and gets the return signal from underneath this cover here. The return signal bouncing off the plankton at different depths. It's Doppler shifted because of the velocity of the water, just same as your red blood cells. To give a Doppler shift to the sound to the doctor, so you can measure flow of the ocean. Underneath the ship here are these 2 drop keels, look like centerboards, but they're nothing to do with stability. Don't worry, they just enable us to get sample water clear of the ship's hull. And in front of it is this, looks like a space shuttle. It contains the swath mapper. So this measures all the seafloor for these volcanoes and canyons. It also sub-bottom profiler, looking for beneath through the mud or rock seafloor. These instruments here, a lot of fisheries instruments for measuring 333 kilohertz. There's a standard fisheries ones for 38 kilohertz, etc., and acoustic current measurement. So it's a really sophisticated piece of kit. On the other first science voyage I had in 2015, we were steaming back into Sydney, and we discovered these 4 volcanoes, and with the big caldera, but they're 4.5 kilometers deep. But they weren't on the map, so that was kind of exciting to discover that. We made a bit of a media splash with that. That's where they are. You can see on Google Maps, there's a bit of a bump there, but anyway, we found them. So that's what we're telling everyone. And on the way into Sydney Harbour, we went over swathed Browns Mountain. Some people it should be called Mount Woolnough. And very productive fishing area there. Many of you probably been out there yourselves. It's only 20 nautical miles off the coast. And there's the summit. This one is a 150 million year old volcano. So it's seen sea level rise and sink. Possibly Aborigines would have gone out there 12,000 years ago when it was exposed, and maybe just exposed. But nevertheless, it's only comes up to nearly 375 meters from the surface. It's sufficient to cause rotation of water and drives plankton, bait fish, and your yellowfin. So I'd like to draw this up. I've brought you back to Sydney. I want to leave lots of time for questions. So Sims started here just here at Chowder Bay, and I know that the squadron has, when the northeasterly wind is blowing, I've been there with Adrian's boat coming up here and round the mark, and we're just off Sims. So it has actually over 100 scientists now and students to do challenging, expensive, sometimes unsafe work like marine science. We have to have collaboration to get the economies of scale to keep the boats and the safety and the diving and all that kind of stuff. So we have a seawater lab here that pumps in seawater from the pump house just off here. The Navy have been very gracious in letting us. We have research labs with all kinds of genetics capability, looking for toxins in shellfish. And there's the acoustic telemetry guys who look at fish, and this is the main office and building here. So it's a genuine four-way partnership, and we've got a number of state partners, and of course we're IMOS and CSIRO. The Department of Defense are or were as part of SIMS as well. So it's been a great shot in the arm for all of us to get this going. SIMS is going gangbusters. They're not just looking at pointy head research, they're actually doing applied work, trying to transform the 50% of the foreshore in Sydney Harbour is vertically, concrete and walls. So they're trying to make them more biologically attractive so we can improve the fisheries harvests in Sydney Harbour and the diversity. There's over a year, there's about 600 species of fish in Sydney Harbour, which is as many species you find in the entire North Atlantic. There's our former director, Peter Steinberg. He just stepped down last year, getting his hands dirty for once. And this has been a great project, also doing a lot of this at Barangaroo on that whole development as well. And the other one that I've been involved in is the offshore artificial reef program. The first one went in. These are designed artificial reefs, not just sinking a wreck. These are designed to enhance the supply of plankton to the fishery, and therefore so the fishing is sustainable. And we did this. These reefs are going in willy-nilly, quite surprisingly so for many people, and a smiley face here because we're involved with this deployment to assess its productivity, those with towers versus some of those without. So this is when it went in 2011, and we did a lot of work on this one, including looking at acoustic telemetry of these tagged fish hanging around the structure. These little Mado here are chock full of zooplankton, and they get hammered by yellowtail kingfish, which is really interesting. So the question is, how do the towers work? And that's what we're doing with SIMS. But just to remind people that you think that all the fish you see on the temperate rocky reef is all based upon kelp. It's not. About 70% of it just comes on the supply, the drift of plankton delivered by the Australian current. So hopefully now you can get your questions. I'll stop my sharing just a second. I would like to thank the Royal Sydney Yacht Squadron, Sir John and Zach and David. I do have a number of oceanographic colleagues who've taught me oceanography. I'm a biologist by training, but the last 30 years I've learned as much as I think I can. I'd like to give a plug for the Sydney Institute of Marine Science Foundation. Jazz is listening in, and if you want to receive an invitation to our major fundraiser with the Emerald Gala dinner, we're optimistically suggesting 20th of October. Clearly, COVID might derail that, but we're just putting it out there. And there's her contact details. And if you want the SIMS newsletter, please contact Heidi or just go to there. And there's our website as well for more information for that. So do you have any questions? And so we'll use it because then in a Zoom sense, it's a bit difficult to do this. I can see I've got a couple there already, but John was quite shrewd and said, look, people might be a bit shy. So let's just kick off with some of my questions. That'll prompt yours, and then I'll stop sharing the screen and we'll go to the Q&A panel, okay? And the first question he asked me is, what is the link or best source of up-to-date information on the current eddy locations velocities? And you can go to this ocean current, imos.org.au, okay? So I'll take that link in just a second. How accurate are the close inshore currents and the countercurrents shown on the BOM website, the Bureau of Meteorology? And they're not great. This is a product that's meant for commercial shipping and for the Navy. And if we really want to know what's happening on the shelf, and even this stuff is not ideal on the continental shelf, which is really where we want to sail. We know that, and it's a work in progress, but we're definitely getting a lot better than we were 10 years ago. And John says he's also interested in the meeting of the currents off Coffs Harbour and Salisbury Islands and the effect this has on the abundant sea life in the area. And the answer is, of course, that mini separation that I mentioned south of Cape Byron. Of course, these eddies that especially the clockwise cyclonic upwelling ones that seem to hover there where that shark attack occurred. And these canyons, there are some magnificent canyons. I got some images if you're interested from the investigator showing you these deep canyons that go all the way down to 2,000, 3,000 meters deep. And they shunt that cold water right up into the Salisbury Islands. And while we were there, there were some big pilot whales going underneath us. But also lots of fishing gear, lots of floats that had popped up because the EAC East Australian current had moved offshore. The eddy was there. Less currents, floats could reach the surface. The fishermen were busy trying to pick them up, these traps. So this is where you go, John, to this website, oceancurrent.imos.org.au. And this is a screenshot from this evening. And then you can, here you got sea surface temperature image for anywhere around Australia. And you got a bunch of zoom in panels. There's some news and gossip if you're an ocean nerd. I love this, the students love it. And the next panel down here, just off the bottom of my screen, is shows you ocean color. There's only about a third of the images in ocean color because it's very sensitive to moisture in the atmosphere and cloud cover, whereas the SST is not as sensitive to that. So if you click on this anywhere around here, this image, you get this one with a bunch of zoom ins. And of course, I always go to this one off Sydney. But heck, you might want to see what's happening, what the Lewin current is doing. We'll dive in. And the New Zealand's in there as well, which is great. This is your BOM site, I think, John, correct me if I'm wrong, I'll hand over to you in just a tick. But you can see that the continental shelf is not well resolved here at all. And it's really, you can dodge this, that'd be a smart move, but you probably already knew that. So unless you're going to go to Lord Howe Island, and even we've been out there on the ship going to Lord Howe, and sometimes even using ocean current, the velocity, the general shape is right, but the actual precise geographic position sometimes is out of whack because of what I showed you that example earlier. So you've got to watch your sea surface temperature image as well. And your last question, John, these are these canyons that have been mapped all around Australia. This is a low res version, but there's heaps of canyons. The one off Newcastle is dramatic. You can still see the plunge pools where the Hunter River just cascaded off the edge of the continental shelf and scoured out. And yeah, I mean the Aborigines 12,000 years ago would have harvested on this continental shelf and would have seen water cascading down there, and it's kind of makes you think, doesn't it? So this is the canyon system off North Solitary Island. It's only 19 kilometers off North Solitary, and it's the biggest one on the eastern seaboard. And I've tried a number of occasions to mount an expedition to look at this. And I've tried with Eric Schmidt, the founder of Google Earth, and his Schmidt Institute of Oceanography. We got close, but because he has an ROV, a remote operated vehicle, to actually get inside here. But I'll still keep trying. We just put an application in early this year. Yeah, and this is what the canyon looks like. So it's 6 kilometers across. It's a big one. And I think that will probably do for answering your questions. And I'll stop sharing. and we'll hand back over to you, John, and I'll look at these Q&As.
Well, first of all, Ian, thank you very much for a very, very, very interesting presentation. So much detail in such a short time. Hard to take it all in, but very interesting. And thank you very much again on behalf of the squadron and from David. And also there was a message from Jazz who said it was a really great presentation. I've got 5 questions here. And the first one's from John Taylor, who says that how advanced are you at being able to predict ocean currents into the future, say a week or 2 or more?
Yeah, good question, John. I'm perhaps not quite the person to answer it. I know people who would be, but I'll do my best. So you can now, there is a method for predicting ocean currents, and you can go out to a week with, depending on the area, with moderate confidence. And it's based upon all that sea level anomaly, sea surface temperature, but then you've got to add the winds on top of that, the surface winds, which then makes things, and of course the sea state, how rough it is, it gets a little more complicated. But you can make, Bureau of Meteorology makes good predictions actually for up to a week. And, they could even look out to give you precise currents for any, obviously it's got, the Department of Defense is very interested in this because they would need to know, but also for shipping, they can save many tens of thousands of dollars in fuel by following these predictions. I'd like to know if you know of any shipping operators who do use this product to try to save fuel costs. I'm sure they would, but I don't work in those circles, so I'm a bit naive.
Well, thank you. I understand that therefore a week would be predictable, given that the weather patterns would be also predictable. But once you get out of there, you're a little bit in grey territory. So the next question came from Janie Whitty. Great presentation, thank you. Do you see coral reef forming south of Lord Howe Island?
South of Lord Howe. So that's Ball's Pyramid is south of Lord Howe. It's an interesting place. I don't know if you've sailed there and hung around. It's just kind of almost creepy seeing all these volcanic formations. So I haven't snorkeled on Ball's Pyramid. I'd love to, but I have obviously at Lord Howe, and the coral is actually doing fairly well. They have suffered coral bleaching events there. Interestingly, the hard corals are susceptible to bleaching and chucking out their little zooxanthellae because of stress of warm water, whereas the soft corals seem to do quite well. And so there are a lot of research by all the lab studies trying to figure out how they can do that. So to answer your question, I don't know about south of Lord Howe Island, but I'll tell you that if you're seeing just here at Manly in Cabbage Tree Bay, you can go snorkeling and find, wanted to put a picture of this in my talk. You can find stands of kelp because it's a reserve, so kelp grows relatively well there. It's a natural ecosystem. It hasn't suffered for like other parts of the Sydney coast. You see kelp, and right beside that, you'll find hard coral. Staghorn coral growing up. You can take a picture on an underwater camera of coral and kelp and climate change in action. So you're seeing corals appear on Soldier Islands. You're seeing corals appear now off Sydney. There's quite a big patch off Bondi, according to my colleague David Booth at University of Technology Sydney. So I would not be surprised if they had the time and technology to look at Lord Howe or to look at Ball's Pyramid. You would see increasing coral growth in that area, but it is suffering from warm water as well.
Yes. Another one from John Taylor.
Yes.
Could you tell us a little more about progress in harnessing ocean currents for power generation? That was one of your quick.
Yeah. I put there's a little taster. Good question there, John. So again, not me, but I've read papers by my colleagues, Professor Meninya Rowan. She is actually currently in New Zealand, but she's a very active supporter of SEMS. And my colleague, Dr. Armandine Schaefer, who's a wonderful mathematician and an oceanographer. So they did the analysis of looking at power generation and where would you put big turbines into the East Australian current, because since the East Australian current is strengthening, it sounded like a good investment to look at. But they also put into their maths the logistics of getting the power off the turbine onto the coast and being transported to a nearby community that could actually use it in a cost-effective way. And when you add that equation into the maths, it comes out that actually off Coffs Harbour and those areas in central New South Wales, northern central New South Wales, like south of Byron, and where there's a growing population centre, Port Macquarie, those are the places where you would put in a turbine. Now, admittedly, the current is not as stable there. It's going to be it's a little more flaky compared to further north off Stradbroke Island, but that's okay because it comes out in the overall cost benefit that it is viable. Some of the reports I've read said that the technology is not there yet because you've got just the maintenance, the labor, the costs. We're not there yet. You can get better technologies from wind. Solar is absolutely incredible. When I went to UNSW as a young lecturer in '91, I think they just cracked 20%, and now they're well past 30% efficiency from solar energy into power. So it's really, solar is just taking off, and then of course you've got the storage issues, but hydrogen cells are very exciting. So yeah, you've got to combine who's going to use it with the oceanographic conditions to produce it.
And the stability of all the grid is another issue.
Yes.
So one from Stephen Face. He said, I have used the Windy app. It has a current as an option with a few days forecast. The question is it any good?
Yes. Great question. Because in my little laser, a lot of these sailors at Greenwich Flying Squadron swear by Windy app. Yes, it is. It's about as good a product as you can get. So it tells you, obviously it's the winds. It does it give you the currents there, John?
Well, that's what he said. Stephen said that it has an option with a few days forecast of current.
Yeah, that would be, I don't know. I don't know. I presume they use the Bureau of Meteorology product, which is not very good on the shelf. It is what we call a data assimilating model, meaning that you have a computer model to look, and then it improves it. It nudges it with actual observations. So it nudges it with sea surface temperature. It nudges it with sea level anomaly, and the winds. So I have not used Windy app for currents. I've only used Windy app for winds, and for winds, it's great. I will take that question on notice. Thanks, Stephen. And it's a good question. I know exactly the person to ask. I can actually, firstly, if you want a copy of PDF of my talk, I could send it to you, John. And secondly, I'll reply to you. I know just the person to ask about Windy app for currents. He sells a TP52 and an 18-foot skiff. So he's the guy that does a lot of those moorings off Coffs Harbour as well. Tim Austin, a great sailor and an oceanographer. So he would know the answer to that question about the currents.
I have one that I haven't written. That is that I noticed you talked about sea urchins and kelp, I think off Solitary Islands, was it?
So that's right. So the sea urchins and kelp, particularly off Tasmania, is where the interaction is most serious.
So kelp is the staple food of sea urchins, I think. Is that correct?
That's right. Oh, it is nirvana to sea urchin. They just happily munch it down, and they form plagues. So sea urchins, and in a similar, like analogous way, the crown of thorn starfish in the Great Barrier Reef that eats corals. This particular group, be they sea urchins or starfish, they are related. They have this capacity to form plague proportions. It has occurred from geological deposits. But I'm sorry, I interrupted your question. But yes, the sea urchins like to just devour, voraciously eat kelp, and usually kelp can keep up with it because lots of things like to eat the sea urchin, like lobster. and like some of the snapper, especially the nice little small ones. They scrunch them up like popcorn. But unfortunately, you know, fisheries is being what it is. We've probably taken a bit too many than we should have. You can take a sustainable harvest, and so therefore the urchins had been released from the predator pressure of those lobsters and those fish. So more than 50% of the rocky reefs from Port Stephens all the way down to Cape Howe off Victoria are classified as urchin-dominated barrens. So they've munched out more than a lot of the kelp. Now, kelp also feeds abalone, and abalone is worth big bucks, a lot of money. And lobster use the kelp for habitat. So the loss of this kelp has a major impact upon the productivity and the value of the coast. So there's a lot of research going on how can we get not just kelp, but also another related species, sargassum, to regrow, to improve the productivity.
My question was, is there any research being done to be able to try and counter the effects of the sea urchins coming south, which is a bad thing to some degree? We need more lobster, perhaps, to be able to eat them.
You know, so
the
southern, yeah, there is. The Fisheries R&D Corporation funded work of my colleague at the University of Tasmania, Craig Johnson, and they actually get these big super jumbo lobsters that probably a bit tough anyway, and the fishermen donated them, and they put them onto where these urchins were. And these things, this southern rock lobster, love to eat New South Wales urchins, and they could videotape them, and they can see them with acoustic telemetry that they stalk over, and these things are as big as a basketball with all those spines, and they can just rip them up off the seafloor and go into the mouth, and they go through 2 of these urchins a night. And so that was amazingly, so yes, you can do the research. You can shift these big, because you need the big lobster because they're immune then to predators like seals and fish. So that was a really nice bit of sort of eco-engineering to how we can restore this balance. More SIMS has been actively involved with actually how to regrow sargassum, the crayweed, and they've actually now found that you can put out little crops, they clip it off, stick it down the rocks, and it releases lots of little babies. And they've now, like in Little Bay off Botany and those areas, they're now recolonizing sargassum, because the urchins have backed off for a variety of reasons. So that's actually a bit of good news, is that these eco-engineering projects, where my colleague Adriana Vergas, the community of Manly, are completely behind this. And even now she's going into replanting of seagrasses. When they get washed up after storm, we can keep them alive and then replant them, and they grow really well. So there's lots of that kind of restoration ecology. It's a big growing field, and SIMS is very actively involved with that. So yes, there is a lot of research there, John.
Okay, 2 more questions. So we've got just a few more minutes before we our scheduled time is up, although we don't have to finish that early. This is from Matthew McCann, and says, Ian, you are a fantastic presenter. Zoom is a very low on audience feedback. As you are a biologist, what are your favourite dive sites?
Yeah, well, it is Ferry Bower. I've been there. My son got into diving, and Ferry Bower is there at Manly, because the fish aren't stupid. Their behavior is completely different. You can just be that Ferry Bower, and there's mullet and brim and so on coming up to you, and you're drifting along, not really noticing where you are, and suddenly the fish aren't as friendly, and you've gone outside the reserve. It's extraordinary. So that is a favorite for that reason. I've often gone snorkeling, and I like to snorkel more because it's more physically demanding, at Manly or at Harbour Beach along the foreshore there. But you can see the occasional big wobbegong, but occasionally the spear fisherman comes in with this great monster mulloway, and I realize, well, that's not. So you got to find areas that aren't particularly, spearfishing. It dictates interests. But the other place, of course, it's a must, is to go to Magic Point off Maroubra and see the grey nurse shark aggregation. That was very, very special.
Okay. The last one from Jed Cruikshank, who says, you mentioned a forensic use for barnacles on the MH17 wreckage. Could you elaborate a little bit on that at all?
Yeah, I could send you a paper on it. We investigated that because the growth rates they used in those barnacles were actually derived from a 1907 paper, and it was they were hodgepodge put together, and we didn't realize this until you dug back into that ancient literature. And that's what was being used in 2017 to determine if these barnacles had settled onto that flaperon at the crash site or nearby, because then the shell of the barnacle gives you the temperature of the water. And the numerical modelers looking at all those Lagrangian drifters could say, we think we know where that is, but the key to us is, did it land in warm water or cold water? And so we started looking at this, and we just found out that they weren't, because it was discovered, 15 months after the plane disappeared. And these barnacles, from our revised growth rates that we actually had a student did, and we raised them, we had barnacles growing on the mooring off Bondi. Yeah, we found that they were only like less than 3 months old.
Right.
But it also transpired, helped us with forensics. For example, when a shoe with a human foot inside it washes up on a beach in southern New South Wales, then they also asked us about those barnacles that were very small ones that were growing on that. So we think that in forensic science, where they use the flies that occur that colonize a body in the woods, and that now it's quite precisely known as to when that body was there. We would say, well, let's do something now with barnacles about their growth rates. There's a whole ecology kind of fun stuff, but also a useful tool for the police, for if a yacht is found drifting, or if a piece of rubbish or garbage has these goose barnacles growing on it, we use them, their size, their growth rates, their isotope content that tells us the temperature. Can we use that as a forensic tool? So it's we've put it out there, and we're getting a lot of interest.
So finally, that's the end of the questions. Just a couple of chats from Jazz Chambers, who congratulate you, Ian, on an absolutely fantastic talk.
Thank you very much. Thank you, Jim.
A demonstration project in the wings in WA. Something about another little.
That's an ocean energy demonstration project, John. Just in response to that one. So it's quite a big one to watch down in Albany.
Oh, Albany, okay. Well, Ian, Jazz, thank you very much again. It's
My
been
pleasure.
a wonderfully interesting evening. And I'm sure I can speak on behalf of the whole cruising division and the audience that it's been fantastic. Thank you very much.
Thank you very much, John. Hope to see you at the club sometime soon.
Thank you, Ian. Good evening, everybody.
Have a good night.
Thank you.
See ya.
Great. That went very well. I've still got about 32 people still on the call, but they're slowly logging off.
So,
Okay, Jack. All right. Thanks, Ed.
Just so
okay,
thank you very much.
that was
I
recorded.
will-
Well done. Well
We'll
done.
Yes.
We'll get some
Yeah.
statistics of how many people are actually logged on later on.
Yeah.
Yes. So I saw a maximum of 67 people,
67.
but that could be higher, or it could be a bit higher.
Okay.
And then yes, the recording is just being processed now, and I'll get it up on the website by tomorrow morning.
Thank you.
It'll
Very
be on
much.
the website in the morning, will it? That's soon.
Mhm.
Well done.
Yeah.
Fantastic. That's really good.
No worries. But
Okay,
yes,
thanks,
I'll
Doug.
talk to you offline.
Okay.
Have a
Cheers.
good night.
Good night, everybody.
Thank you. Went very well. Thank you.